So today we'll be talking about LL1 parsing, which is a concept that we introduced last time. Today's lecture is going to focus on the first and follow sets, which is a concept that I introduced briefly in the previous lecture. In today's lecture, we will discuss all the details of calculating first and follow sets and how they relate to LL1 parsing and why they are important in LL1 parsing, or important for proving that they're important for both the sake of proving that a parser is an LL1 parser and for implementing that. So when we say LL1, what do we mean by LL1? So the first L is we scan the string from left to right. The second L, leftmost derivation, and one is one symbol of look ahead. Okay, because there are parsing algorithms that have more than one symbol of look ahead. In theory you can have anything, but in practice there is a limited number of symbols of look ahead. Now, in order so what's the key idea? What can make, based on what we have discussed last time, what can make an algorithm good or suitable for LL1 parsing? What makes it good? What is LL1 parsing good for all grammars? No. So what kind of grammars? Okay, not necessarily. So not every right recursive grammar is good for LL1, but in this case, converting this grammar into a right recursive grammar indeed made it LL1, or made it suitable for LL1 parsing. But what's the key idea? What's the key property that you should have in order for LL1 parsing to work? In order to be able to determine at each step which production or which rule to use, what property must the grammar have? Well, okay, so let's first write the right recursive before we answer this question. So the right recursive form, remember, so it's left recursion is alpha, or in the left recursive form is x alpha 1 or x alpha 2 or x alpha n or beta. This gets converted into x is beta x prime, where x prime is alpha 1 x prime or alpha 2 x prime or alpha n x prime or epsilon. Okay, so now in this case, we did this last time, so expression is going to be term, because term is the beta term, expression prime, where expression prime is plus term expression prime, or minus term expression prime or epsilon. And term is what? Factor. This is the beta. Factor term prime, where term prime is times factor term prime, or divide by factor term prime or epsilon, and the factor doesn't change. Because it doesn't have left recursion in it. And when we did the parsing, when we did the derivation, sorry, so we don't need this. When we did the derivation, we used x plus 5 times y, I believe. That was the example that we used. And we started with an expression. And then for the expression, there is only one substitution, which is term expression prime. Then for term, there is only one substitution for term, which is factor term prime. So the key idea is that this works if there is only one alternative, one valid alternative at each point. And we did factor term prime, and then for factor we did number, we did identifier. And that identifier is the x. Then for term prime, we had multiply, divide. We didn't have any of them because after that the pointer is going to be at the plus. So this is an invalid option for term prime. This is an invalid option. Why? Because we are not seeing any of these star or divide, multiply or divide. So these are invalid options. This is the only valid option, which is epsilon. But in fact, let's stop here. In fact, epsilon would be valid. The epsilon would be a valid option. We are seeing a plus after the term prime. So we are substituting epsilon for the term prime here. So substituting an epsilon for the term prime would be a valid option only if what comes after a term prime can be a plus, or if the plus, the symbol that we are seeing in the input, after the term prime is something that can follow a term prime. So this is the concept of follow, where each symbol in the grammar has a follow set. This follow set is the set of symbols that can follow that symbol in the grammar. And there is also a first set, which is the set of symbols that a string derived from that symbol can start with. So let me define first and follow. Okay, maybe we can use this space. So the first of x is the set of terminals that can appear as first symbol in a string derived from x, while follow of x is the set of terminals that can appear immediately after a symbol, a string derived from x. Well, in fact, let's look at the first and follow sets for the symbols in this grammar. So first So we calculate the first and follow sets for all the variables or non-terminals in the grammar. So we need first of expression, first of expression prime, first of term, first of term prime, first of factor. Do we have other variables? So we have expression, expression prime, term, term prime, and factor. So now, in order to calculate the first set, it's usually easier to start with the variables that are at the bottom of the grammar. You know, low-level variables. And in this case, the lowest level is factor. Now, what can a factor start with? What are the symbols, the terminals, that can appear in a string derived from factor? Well, this is a terminal. Number is a terminal. Identifier is a terminal. And if we substitute expression between parentheses for a factor, what will be the first symbol? Open parentheses. So a string derived from factor can start with a number or an identifier or open parentheses. Right? A string derived from, I put it at expression. Sorry, I meant factor. Number, identifier, open parentheses. Okay? So a string derived from factor cannot start with anything else. Now, what about term prime? What can a term prime start with? So clearly here, with this rule, it can start with a multiply. Here, divide. Or it can start with nothing when we substitute epsilon for it. So a term prime will either start with multiply or divide, or it will start with nothing. By the way, later on we will give more detailed and complete rules for computing the first and follow sets. Now we are doing it in a more intuitive way. But later on we'll give more clearer and more precise procedure for calculating computing the first and follow sets. Now what about term? Now term, we don't see a terminal explicitly in the definition of a term. So where do you think we should look for the terminals that a term can start with? In fact, because here it says a term starts with a factor. Factor is a variable, it's not a terminal. So we should look for what a term starts with in the start of factor. In fact, since factor is can be the first symbol in a term is going to start with whatever factor starts with. Okay? So factor can start with number, identifier, and open parentheses. Now that's not all. Well, in this case, this is all, but in general, the start of, well, let's give an example. So if you have x is A1, A2, A3 through AN. Okay, in general. So in this case, in this example, X is term, A1 is factor, A2 is term prime. Okay, but in general, if you have something like this, and you would like to calculate the first set of X, will it be sufficient to say that the first of X equals the first of A1? Will that be sufficient? Why or why not? Why wouldn't that be sufficient? Or in what case may X start with something other than the terminals in the first set of A1? Yeah.
If epsilon is in the first.
Yeah, exactly. If in the first set of A1 we have an epsilon, if there is an epsilon in the first set of A1, this means that A1 can vanish. We can substitute nothing for A1. And if epsilon appears in the first set of A1, we should also include the first set of A2 in the first set of X. So we should say it's first of A1 minus the epsilon union first of A2 minus the epsilon. Well, and this should be like this. Now, will it be enough to put the first of A2? No. What if A2 has an epsilon in its first set? So if this can be an epsilon, then an X may start with an A3. Right? So if both of these, if we can substitute epsilon for both A1 and A2, an X may start with an A3. And then we should include everything in the first set of A3. And how far should we go? Or when should we stop? When we reach something that doesn't start with an epsilon. So if, say in this case, A3 cannot be replaced with an epsilon, or A3 does not have epsilon in its first set, we stop here. And we just include, if the A3 no epsilon in its first set, then we just include union first of A3. Now, why are we not including the epsilon? So if first of A1 has an epsilon in it, and first of A2 has an epsilon in it, why aren't we saying that epsilon should go in the first set of X? What does it mean? When we say that epsilon is in the first set of X, it means that we can substitute epsilon for the whole X. And substituting an epsilon for the whole X is possible only under what condition? Under what condition will it be possible to substitute epsilon for the whole X, which consists of the concatenation of these n variables?
All of them are epsilon?
Exactly, yeah, exactly. If all of them have epsilon in the first set. If all of them have epsilon in the first set, only then it will be possible to substitute X, to substitute epsilon for the X. As long as there is one of them that cannot be replaced with an epsilon, the X cannot be replaced with an epsilon, because the X is the concatenation of these n variables. Right? So now the general rule, you always add the first set of A1, no matter what, but you add the first set of A2 only if epsilon appears in the first set of A1, you add the first set of A2. And you add A3 only if epsilon appears in the first set of A2. So you keep going until you either hit a variable that cannot be replaced with an epsilon, or you reach the end. You go through all of them, and all of them can be replaced with epsilon. If all of them can be replaced with epsilon, you add epsilon to the first of x. Okay? So if all of them, all of A1, A2 through AN have epsilon in their first sets, we put an epsilon in first of x. Well, now this is in general. Now the case that we are working on, which is term, is very easy. Does factor have an epsilon in its first set? Yeah, factor does not have an epsilon in its first set. So this means that the first set of term is limited to the first set of factor. In other words, term prime will never be the first thing in a term, because this thing cannot have an epsilon, cannot be replaced with an epsilon. Now, this is term. Now, what about expression prime? So here clearly, yeah, so that's plus. Now, should I go beyond the plus? Now, in fact, this is, this is my A1, this is my A2, and this is my A3. And my A1 is, in fact, a terminal. And a terminal, by definition, does not have an epsilon in its first set, because a plus cannot be replaced with an epsilon. Only a variable can be replaced with an epsilon. An actual terminal cannot be replaced with an epsilon. It's an actual terminal. So, the first set of a terminal is the terminal itself. Right? So let me write this somewhere in this super small board. So the first of a terminal is the terminal itself. So the first set of a terminal is a set that consists of a single element, which is the terminal itself. Okay, and so now for expression prime, I have plus, I have minus, and I have an epsilon. Okay. Now for expression, what should I look at for the first set of expression? First of term. And first of term is known. That's why it's good to do it bottom up. First of term is number, identifier, and open parents. Now, should I consider the first of expression prime? Why not? Because term does not have an epsilon in its first set. Term does not have an epsilon in its first set, so I shouldn't consider the first set of expression prime. But if term had something like this, hypothetically, if we had this for term, and term has an epsilon in its first set, and so epsilon can be substituted for a term. In this case, I should look at the first set of expression prime. But this hypothesis does not apply here. Okay, now let's look into the follow sets. And it's the follow set is probably more, it's probably trickier. So let's look into the follow of expression, follow of expression prime, follow of term, follow of term prime, follow of factor. Now, in the follow set, the first rule in the follow set is always I always go to the start variable, and I put the end of file in its follow set. This is step number 1. Why is that? So the start variable, I'm parsing. The start variable is the biggest variable. So in fact, the start variable is the whole string that I'm parsing. Right. So this whole thing will parse into an expression. So this is going to be an expression. The whole string is an expression. So the whole string is followed by, the end of file or end of string indicator, which is, here we use end of file. Some books use the $sign. So the $sign or the end of file marks the end of the string, and the start variable will always be followed by the end of file. In fact, it will not. This means that it will not be followed by another symbol within the string. But the start variable, if the start variable appears on the right-hand side, it may be followed by other things as well, which is the case here. We scan for expression on the right-hand side, and where will we find it? In fact, now in factor, what's that expression followed by? Yeah, it's followed by closed parentheses. So we add that as well. So an expression may be followed by an end of file or closed parentheses. To understand this, consider this example. If you have something like, A plus B times 5 plus 6. So when you derive this is going to be an expression. The whole thing is an expression. But this is also another sub-expression within the expression. So the big expression is followed by end of file. And this small expression or sub-expression is followed by closed parentheses. Okay? So there are two possibilities depending on whether it's the big expression or a sub-expression within the big expression. Okay, now the rule for finding the follow sets is scan for that variable on the right-hand side and see what comes after it. Scan for it on the right-hand side and see what comes after it. So for expression, we scanned and we only found this, and what comes after it is closed parentheses. And then we are done with expression. Now next we go to expression prime. we scan for expression prime on the right hand side, and we see what comes after it. Now here we find expression prime here. Now what comes after this? Here we don't see anything after it, but this rule tells us that expression prime can be the last thing in an expression, or the last piece of an expression. And what does that tell us about what comes after expression prime? If expression prime can be the last piece in an expression, the last variable in an expression, what does this tell us about what can come after expression prime, given that expression can be followed by either end of file or close parentheses? Expression prime, which is the last piece of it, will be followed by the same thing, right? So if an expression, if an expression can be followed by this, then an expression is a term expression prime. So you can think of this as term expression prime, and then expression prime is followed by an end of file. Okay. Now here, what does this tell us? This tells us that expression prime is followed by whatever follows an expression prime, which is useless. So here it says expression prime is followed by whatever is in the follow set of expression prime, which is useless. And this is the same. Now, do we have any other expression primes? No. So we are done with expression prime. Then we move to term. Now we scan for term on the right hand side, and this is the first term that we find. Now what do you think? Given this occurrence of term, what should we put in the follow set of term? Logically? Yeah, think logically. What should be in the follow set of term? Expression prime. Be more precise. What do you mean by the first set of expression prime? So if an expression prime follows term, then we should put everything in the first set of expression prime into the follow set of term, because a term is followed by an expression prime. So we look at the first set of expression prime, and we'll see this plus, minus, and epsilon. We put everything except the epsilon. And I will explain why. So we'll put the plus and the minus, but we will not put the epsilon. In fact, epsilon can never appear in the follow set of any variable. So let me write it down. A follow set can never have an epsilon in it. And why is that? The follow set means the set of terminals, that can follow a string derived from a given variable. Now, can a string be followed by nothing? No, it cannot be followed by nothing. Because if that string is in the middle of the big string, it will be followed by something. If it's in the middle of the big string, it's going to be followed by some other symbol. And if it's the very last string, if it's in the end, then it will be followed by end of file. So if you are at the end, you are followed by end of file. If you are somewhere in the middle, you are followed by some other terminal, some other symbol in the string. So it never makes sense to say something is followed by epsilon or something is followed by nothing. While it makes sense to say that something starts with epsilon, why? Why does it make sense to say something starts with, or in the first set I can have an epsilon? That makes sense. Because having an epsilon in the first set means that you can substitute epsilon for this. Basically you can skip it in the derivation or substitute epsilon for it. So conceptually, it makes sense to have an epsilon in the first set, but it never makes sense to have an epsilon in the follow set. Any questions on this? Okay. Again, having an epsilon in the first set means that this symbol can be skipped by substituting epsilon for it. We can substitute epsilon for this symbol, for this variable. But epsilon doesn't make sense in the follow set because a variable cannot be followed by nothing. It's either followed by one of the symbols here or followed by end of file. Okay. Now, for term then, term is followed by expression prime. So we put the first of expression prime. And here term is followed by, okay, so one more thing. Now that's why computing the follow set is a little bit tricky. Now term is followed by expression prime. But expression prime has an epsilon in its follow set, which means that I can substitute epsilon. Now if I can substitute epsilon for expression prime, this means that there are cases where the term will be the last thing in an expression. So when I substitute epsilon for expression prime, the term will be the last thing in an expression, which means that a term can be followed by whatever the expression is followed by. So I can then put everything in the follow set of expression into the follow set of term. So I add end of file and close parentheses. Why? Because if this can vanish, an expression may end with a term. Okay. Now, are there any other occurrences of term? So here term is followed by expression prime, and expression prime has an epsilon in its first set, so term can be followed by what's in the follow set of expression prime, which is already there. End of file, close parentheses. Okay, now what about term prime? Term prime, we scan for it on the right hand side. So this is term prime. What should I put in the follow set of term prime here? The follow set of term, because term prime is the last piece in a term. So I put the follow set of term in the follow set of term prime. So everything here gets copied into the follow set of term prime. This is going to be useless. It's going to tell me put in the follow set of term prime whatever you have in the follow set of term prime. Okay, so this is not going to add anything. Now, what about the follow set of factor? I search for factor on the right hand side. I find this. This is followed by term prime. So now what should I put in the follow set of factor?
First of term prime.
Yeah, exactly. First of term prime, excluding the epsilon. First of term prime, excluding the epsilon. So that's multiply divide without the epsilon. But then I ask myself, can term prime be replaced with an epsilon? Term prime can be replaced with an epsilon, which means that factor can be the last piece in a term. What does that tell me? Put. So this can go away. So now factor can be the last piece in a term. So I should put everything in the follow set of term in the follow set of factor. And follow set of term has plus, minus, end of file, and close parentheses. Now let's check, do some sanity check, if this makes sense. An expression can end either with end of file if it's the big expression, or it can end of close parentheses if it's a sub-expression. What about a term? A term can be followed by either end of file. When will that happen? If it's the last term. Or it can be followed by close parentheses if it's the last term in an expression between parentheses. It can also be followed by a plus or a minus, because the plus and the minus separate terms from each other, right? So this plus separates a term from a term. Does it make sense for a term to be followed by a multiply? Can a multiply follow a term? Ever? Why not? Because the multiply can only appear in the middle of a term. By definition, the multiply can only be in the middle of a term. A multiply will never ever be a follower of a term. Right, so this is a multiply. The multiply is inside the term. It will never be something that separates two terms. So this is a term, and you will never have a term followed by a multiply, because in fact this multiply can only be part of the term. So that's why we don't have the multiply or the divide as followers of a term. But it makes sense for the multiply and the divide to be followers of a factor, because this is a factor, and this factor is followed by a multiply. Okay, so the sanity check here is that multiply and divide appear in the follow set of a factor, which makes sense, but multiply and divide do not appear in the follow set of a term, because they can appear only in the middle of the term, not after a term. Okay, so now with these first and follow sets, how does this help us with the derivation, or how does this help us do the derivation properly? So we did that x plus 5 times y, and we started with expression, then we substituted term expression prime, then we substituted for term factor term prime, and then we substituted identifier, and that's the x. Therefore, this term prime. Back to the question that we asked, for term prime, I'm not seeing a multiply or a divide. I'm seeing an epsilon. Is epsilon a valid substitution for term prime? It will be valid only if it appears in the follow set of a term prime. Now I look at the follow set of term prime, and there is what? There is a plus in it, which means that epsilon is a valid substitution. If I didn't have a plus if I didn't have this plus in the follow set of a term prime, I cannot, epsilon will not be a valid substitution. Because I'm saying I'm going to substitute nothing for the term prime, but then I'm seeing a plus. So the plus is going to come after a term prime. If the plus is not in the follow set of a term prime, then this will be an invalid alternative. And by the way, if all alternatives at some point are invalid, what does that mean? What does that mean if all alternatives are invalid? I don't have a single valid alternative. Yeah, the string is not in the language. So it means that the string cannot be derived from this grammar. The string is not in the language. Or in the context of compilers, it means a syntax error. Okay? Now, okay, so we substitute. Now we know that it's a valid alternative. Now for expression prime, I have a plus term. So this is a valid substitution. This is not valid. Why? Because I'm seeing a plus. Now, is the epsilon valid? A valid substitution? Well, does the plus appear in the follow set of what? Expression prime. Does the plus appear in the follow set of an expression prime? So the follow set of an expression prime does not have a plus in it, which means that this is an invalid alternative. Now, the epsilon being an invalid alternative is good news here. Why?
Take the first option.
Because we only have one valid alternative. That's what we want. If we have more than one valid alternative, then the LL1 parsing algorithm is going to fail. We cannot parse this with LL1. We'll have to find another parsing algorithm. Or we have to readjust or redesign the grammar. Either adjust your grammar or find a different parsing algorithm. So LL1 parsing is going to work only if you have one valid alternative at each point or in each step. If you have 0 valid alternatives, this means that the string does not belong to the language. If you have multiple valid alternatives, this means that this grammar is not good for this parsing algorithm. Okay, any questions on this? So now we can substitute for we can get what we did last time. So this is going to be for expression prime, it's going to be plus term expression prime, and then we'll do the derivation that we did last time. But this is just the whole point here is to see how the first and follow sets help us with the LL1 parsing algorithm to decide whether a certain alternative is valid or invalid.